Welcome to the project demonstration of a compact multifunctional power electronic interface for plug-in hybrid electrical vehicles by adding the IOT feature. So in this version we are added the IOT feature to monitor the 4 voltages from the 3 different sources along with battery voltage. So 3 different sources we are using is wind power generation from this wind turbine and solar power generation. And these two are the renewable sources, and another is a dynamo. So the front 2 wheels are acting as a dynamos and back 2 wheels are used to drive this vehicle in 4 directions from these switches. So in this one the hybrid vehicle was developed with renewable and non-renewable sources along with IoT for power monitoring system. So and also it has a microcontroller continuously displaying the respective voltages on the LCD screen, and we are going to charge a battery from this charging circuit. So it has a 4 charging circuits along with rectifier, filter and unidirectional diodes. Rectifier purpose is if the wind rotates in clockwise or counterclockwise, then the polarity varies from this dynamo cables, and that will be rectified with help of this rectifier IC, and filter just to make the high current while charging the battery. And unidirectional current flow purpose we are using 2 diodes. So the purpose of this diodes is whenever the battery is fully charged, then that battery will become the high potential one and the generators will become the low potential when there is no power available from these generators. Then in order to block the current flow from the battery to the generators, either wind, solar or dynamos, then these diodes will acting as a unidirectional current flow. They will block the current flow from the battery to the sources. So this 4 nothing but one is for the solar, wind, dynamo, and there is transformer. So whenever these 3 sources are not available, then we'll make use of a transformer to charge a battery. Right, with help of this transformer we can charge a battery when the sunlight or a wind or dynamo's power supply is not available. So in order to charge a battery from this transformer, just on the power supply of 230 volts to this cable, then we can see the charge light indication on this charging circuitry. So it will get fully charged in a duration of minimum 8 hours, maximum 12 hours, as we are using the battery pack of 12 volts 2 amp. So you can see that there are 6 batteries. In that 3 batteries are in series, and these 3 batteries are in series. So each battery of 4 volt 1 amp, and when we are connecting the 3 batteries are in series, we will get 12 volt 1 amp and 12 volt 1 amp. These 2 are in parallel, so we will get 12 volt 2 amp DC output. And coming to the sources ratings, right, so let us have this. Right, coming to source ratings, we are using the wind turbine 12 volts 20 watts power can be generated from this dynamo. So this one is a 12 volts 20 watts and the dynamo ratings are 1000 rpm. So whenever the wind comes, when this blade rotates at a rotation of 1000 rpm, means 1000 rotations per minute, then it can generate the 20 watts of power with 12 volts voltage. Same for this dynamos also. Here these dynamos are 500 rpm. When these 2 rotates, we'll get the voltage of 12 volts 20 watts from the dynamos also. And coming to the solar panel, we are using 12 volt 5 watt solar panel which can generate the 5 watts power. Right, so whenever the sunlight fully available on the solar panel, then we'll get the maximum of 5 watts with 12 volts. So all these sources are connected to this battery pack directly through this charging circuits, and parallelly the voltage is given as input to the microcontroller PIC16F73 microcontroller through this voltage sensors. So we can see the 4 voltage sensors are connected. In that, each voltage sensor consists of 2 resistors. In that there are 1 kilo ohm and 10 kilo ohm. So right, the purpose of 1 kilo ohm 10 kilo ohm is which will acting as a potential divider. Why? Because we are going to provide the 12 volts all voltages measuring purpose to the microcontroller. The microcontroller operating voltage is maximum 5 volts. So we need to make it is less than 5 volts, so that then only microcontroller measure. So now we are providing 12 volts input to this potential divider circuit, and output from this potential divider is 10:1 ratio. Means if you provide 12 volts, the output from this voltage sensor is 1.2 volts. But inside the microcontroller, we have written the logic to multiply that with 10, as we are using the 10:1 potential divider circuitry. So that's why it has a 10:1 ratio of total 4 voltage sensors. Now coming to the vehicle controlling purpose, we are using this for controlling of the vehicle. Right, actually this is on off switch. So on, So after switching on that, on the LCD, or actually before on this, let us explain about the IoT also. So right after the voltage measures that will display on the LCD, and with help of this ESP8266 Wi-Fi module, we are going to upload the data to the thingspeak. So we can see here the voltages are like, so solar voltage, and next wind voltage, and dynamo voltage, and battery voltage. So these are the previous voltages. While we are testing, we got these values. In order to erase this, we can erase that actually, but before erasing, you should download the data as a backup purpose. For that, go to data import export and download. So it will be downloaded and open in Excel sheet. We can see the date and time, how many samples till now we have collected, and the field 1, field 2, field 3, field 4. Field 1 solar, field 2 wind, field 3 dynamo, field 4 battery voltages. So like this, till now we have collected the total 4 samples. After you took the backup, now go to channel settings, and in that only do clear channel. Check twice before doing the operation. Only do clear channel. Okay, right, successfully done. And after that, go to private view. So total 3 tabs you need to access, and the purpose is private view to see the live data, channel settings to clear the channel, data import exports to download the data backup purpose. Right, after this, before on the kit, go to hotspot settings of your phone. Right, go to hotspot settings, and in that configure the hotspot to project 6324, and password should be 123456789, AB band 2.4 GHz. After configuration these things on the hotspots along with data, now you can on the power supply to the kit. So after switch on the power supply, a welcome message displayed on the LCD screen, and the device will be connected to your mobile phone. You can see that one device is connected. Right, now stay on the screen, and we can get the right. Already we got the data of voltage from the solar panel. So it's 0 volts, as there is no source availability from this one. Now on the LCD we can see that. So when the wind generates, you can see the wind voltage is 1.2. You can see the voltage rising here also. Right, okay, and solar voltage. And coming to the dynamo, and dynamo. So you can see that D nothing but dynamo, S solar, W wind, and dynamo voltage also is appearing here. You can see the lighting also on the charging indication. Right, okay, and here battery voltage is 12 volts. Now let us see the controlling of the robots. So two back, so one is forward, another is backward. It's coming to the right side and left side. Right, let us see that backward and forward motion. Right, so while we are testing, now these are the data we have received: solar, wind, battery voltages. Right.